Hello, this is Dalia Rodriguez, and I'm going to show my demonstration of the second law of Skittles, or in this occasion, corn kernels. What is entropy? In Paul Hewitt's conceptual physics, entropy is defined as the term we use to describe the natural dispersing or degrading of energy. Entropy can be measured by the amount of disorder in a system. More entropy means more dispersal or more degradation of energy. A day-to-day example would be how a new house can go from pristine and orderly to a complete wreck in a matter of years if human intervention has not occurred. So, what about the kernels? In this demo, I will be utilizing a container to shake up the kernels inside it. There are two parts to this demonstration. On the first part, I will be placing 4 plain kernels on one side and 4 blue dotted kernels on the other as separated by the tape in the middle. On the second part, I will be doubling the amount of kernels from 4 to 8, meaning that a total of 16 kernels will be floating around in the system. The trick for both parts is that I need to count the amount of shakes it takes to get the system to become orderly again with low entropy. So, all kernels of one type in one side and the other type in the other. In a simple system like this one with only 4 kernels of each type, the order seems to be disorganized. However, it's still possible after many shakes to get it to become organized. But why does shaking the container cause the kernels to become out of order? Although we're putting in work to cause the shaking to happen, in reality that is kind of the natural state of life. In fact, I'm doing more work trying to get the similar kernels on the same side than getting them mixed up. Dissipation of the kernels across the container seems to be the final product. It really is by pure chance that after all of the shakes, the kernels finally organize themselves back to their original positions. On the first shake though, I managed to get 2 of each kernel type to be in the same side, meaning that 50% of the kernels had become orderly. This event actually happened quite a few shakes. Okay, in this video I'm actually showing when it finally happened, when finally all 4 kernels had become organized. It actually took me 14 shakes to finally get kernels to the same position they were at the start. At some point I thought going from a high entropy state to a low entropy state was impossible, even though I knew for a fact it wasn't. It just took a long time. Showing more how time can deteriorate the order of the system, but suddenly it also makes it go into order again, but very seldomly. Now, what if we double the amount of kernels from 4 to 8 per group? So, what effect does adding more kernels have on the order of the system? Well, it increases the complexity of it. The more parts, the more difficult it is to get them into order. Sure, it is bound to happen for order to be achieved regardless of how complex everything is, but I'm not going to stand here all day shaking a tub of unpopped corn to find out when it does. It's just like the lottery. I bet the probability of winning the Mega Millions lottery becomes a lot higher if the choice of numbers gets reduced from 70 to 5. A whole lot of people would be winning now. Alright, thanks for watching my demonstration. Have a good one.